Um, Based on this drawing, what is true? We're looking for which lines are parallel. Guys, you cannot go by if they look parallel. I've already told you that once. This is 110. This is 60 here, so that makes this 120. Would these be parallel? No. Because in order to be parallel, corresponding angles have to be congruent, or alternate interior, alternate exterior have to be congruent, or same side interior, same side exterior have to be supplementary. So look, 110, 120, and 115. None of these are congruent because those corresponding angles, none of them line up. So let's check these two. This is 60, this is 120. Supplementary, linear pair, that makes this 60. That makes those two lines parallel because corresponding angles there are congruent. Therefore, E and D would be your two parallel lines. So, what can we conclude? A, that D is parallel to E. Next problem. It says, in the diagram below, line N and M are cut by transversals P and Q. What would make the lines parallel? Okay, and in order to be parallel, you just do it backwards. Okay, if you could somehow force the corresponding to be congruent, alternate interior, exterior to be congruent, or same side interior, exterior to be congruent, these lines would be parallel. So let's see what values that we would have to have for these other angles in order to be parallel. In order to be parallel, alternate interior would have to be the same. So 30. Is these two not already equal regardless? You see the vertical angles there? I'm writing down everything I know. 80 and 30s, everybody see the straight line. I believe the straight line, those would have to add up to 180. So I have an extra 70 would make it 180. And that would be enough information. What does X have to be? 70. Because in order to be parallel, alternate interior angles have to be the same. If this is 70 up here, these are alternate interior. Here's a good way to check for alternate interior. You want these two lines to be parallel, correct? You'll have a Z shape. Anytime you have alternate interior, you've got that Z shape. So alternate interior must be the same. Each of them have to be 70. Next problem says that line N intersects lines L and M, that's the transversal, forming the angles shown in the diagram. What value of X would prove that L is parallel to M? These two angles here, McKenna, what's the relationship as far as names? What's the named relationship we give to these two angles? Alternate interior. In order to be parallel, those would have to be congruent or equal in measure. So therefore, we're going to set them equal to each other. 6x plus 42. 6x plus 42 would have to equal 18x minus 12. Let's solve that in our head. Garrett, how are we going to move 6x to the right side? Good. So I now have, instead of 18, I now have 12x's. Garrett, how would I move minus 12 to the left side? Add it, and you would have 54. Last step, let's divide that by 12. It does not divide evenly. So you can use your calculator to divide it, or just reduce it. Anytime you've got a division problem, this is your extra algebra content of the day. Anytime you have a division problem, treat it like a fraction because it is a fraction. Division and fractions are the same thing. Reduce this fraction by dividing by 6 maybe, and you get 9 over 2. If you want to divide 9 by 2, you're going to get 4.5. It's just much easier. If you can reduce that in your head, 54 divided by 12 is 4.5. Or you can reduce it, 9 divided by 2 would give you the exact same answer. So 4.5, which value of X would be B? A transversal intersects two lines. Which condition would always make two lines parallel? So this is just testing you on the same thing. I would know all about parallel lines, obviously. If vertical angles are congruent, does that make the lines parallel? No. If that were true, guys, let's think. That would make every line in the entire world parallel. Because vertical angles are always congruent, regardless. So just because two vertical angles are congruent does not mean that lines would be parallel. If same side interior angles are complementary, does it make two lines parallel? Change that word complementary. That should be supplementary. Then that would be correct. Same side interior angles must be supplementary, so no, that's not true. Would corresponding angles have to be supplementary? Corresponding angles would have to be congruent. Alternate interior angles would have to be congruent. True. That would be D there. Next problem says the dashed line in the figure below represents a proposed bike path that crosses the two parallel streets. The measure of angle 1, which is here, is 32 degrees. What's the measure of angle 2? I didn't have to copy that, did I? If angle 1 is 32 degrees, by name, Pacey, what is the relationship between 1 and 2? Those are alternate exterior angles. Alternate exterior angles are always the same. So if that's 32, then this is 32. Done. That'd be B answer. First proof that's going to be on the test. And I'm not going to make you prove a whole proof of anything. This proof says AC is perpendicular to GE. AC and GE are perpendicular, so you have right angles there and there. GD and BF are also perpendicular. GH bisects, this dotted line bisects this EGD. And the measure of BGC is 36 degrees. Well, I say it's proof. It's not a proof, is it? That's just given. It says, what is the measure of angle EGH? Okay, so here we go. AC is perpendicular to GE. That makes this a right angle. Let's do it in red so we can see it better. This would be a right angle, and this would be a right angle. I'm going to go ahead and put BGC. Let me find BGC. BGC is 36 degrees. We're also given that GD, which is this, would be perpendicular to BF. So that makes this a right angle, and it makes this a right angle. GD and BF. Okay. Guys, if this is 36, it just told us that this BGD is a 90-degree angle because it's perpendicular. If this is 36, then that makes this 54. Everybody follow me? GH bisects EGD. Not only do you have a right angle here, but this EGC, everybody see that, is also a right angle. So do you see that this part, and this is a pretty tough problem, you see that this here, if this is 54 here, how big will this whole angle be? Also 36. But you've got a bisector here. And to bisect means to cut perfectly in half. So what I'm going to do, since the whole thing is 36, I'm going to distribute that and put 18 and 18 there and there. And I don't know what they're asking for. I'm just giving them everything. If that's 36, you also have a right angle here. That makes this angle also 54. And that would make, since you have a right angle here as well, that would make this angle 36. So now let's see what they're actually asking for. EGH. EGH would be 18 degrees. On this next problem, you might be asking, what in the world does this have to do with geometry? If you don't remember, we started off the chapter talking about inductive reasoning. Inductive reasoning is a reasoning based on patterns. So if this pattern continues, notice it says if the pattern continues because inductive reasoning can be wrong. It's saying if it does continue, what would be the next figure in the pattern? Just pointing out that the first figure has 4 dots, the second figure has 3 dots, the third figure has 2 dots, the next figure will have 1 dot, which helps you none at all. They all have 1 dot. The first figure has no lines, 1 line, 2 lines. I would say the next one would have 3 lines. That one has only 2. This one has 3, and this one has 3. So now we're down to A or D. The first triangle is pointing up, down, so that gives you an answer of D. Okay, just look at your patterns. That's called inductive reasoning. Now here's your first proof. What statement completes the proof below? We are given that angle 1 is congruent to angle 2, and unfortunately for you, I gave you that step. Angle 1 is congruent to angle 2, given. We're also given, that's it. No. We're given that angle 1 is congruent to angle 2. We have to somehow prove that angle 1 is congruent to angle 4. So the intermediate step, which I do give you that the intermediate step is proven true because vertical angles are congruent. That narrows down the answers. Since vertical angles are congruent, what would be our actual statement there? Well, it would have to be either 1 and 3 are congruent or 2 and 4 is congruent. But which one would actually help me with this proof? So here we go. Let's try it like this. We're given that angle 1 is congruent to angle 2. And from there we go to some intermediate step. And from there we go to our final answer, which is angle 1 is congruent to angle 4. And we do know that to get from here to here we use the transitive property. And for those of you that know the transitive property, that alone can tell you what your answer is. Transitive property says if one thing is congruent to another thing, and that other thing is congruent to a third thing, then the first and third thing must be congruent. Just from that, and not even looking at the drawing, what has to be the missing blank? Angle 2 is congruent to angle 4. Because if 1 is congruent to 2, and now if 2 were congruent to 4, then we would know that 1 is definitely congruent to 4 by the transitive property. Now let's make sure that fits though. 2 and 4, are they? Yeah, those are vertical angles, so that would fit there. Angle 2 is congruent to angle 4. So as in the following proof, what is the reason for step 4? We're given that transversal K intersects M and N, and we're given that the measure of angle A is congruent to measure of angle B. We want to prove the lines are parallel. They said, okay, here's my given. They also said that A and C were the same because vertical angles are congruent. Then they said that C and B are the same by the transitive property. Well, how in the world did they go there? Look what was given. You were given that A and B were the same. We then said that A and C were the same because they were vertical. So now we know that C and B are the same by the transitive property. So since we know that C and B, look where you're going from. You're going from C and B being the same to now the lines are parallel. Look at C and B. C and B, Hannah, are what type angles? So we're using the fact that corresponding angles are congruent to prove that the lines are parallel. So what's my missing reasoning? Look at this. Okay, here's what not to do. Let me find the not right answer. D. Look at D. If two parallel lines are intersected by a transversal, then corresponding angles are congruent. That's not what we're using. We're trying to prove that the lines are parallel. We're not trying to say they're parallel, so therefore corresponding angles are congruent. We're saying since the corresponding angles are congruent, that implies that the lines are parallel. We're actually using the converse of one of those original theorems, which I believe would actually be C. Is that right? If two lines are intersected by a transversal and corresponding angles are congruent. If corresponding angles are congruent, then the lines are parallel. That's the justification. We're proving that they're parallel because corresponding angles are congruent. Number 24, talk about, there's only two laws we did. Let me remind you of that. As far as when we discussed deductive reasoning, we did law of detachment and we did law of syllogism. The law of detachment said if you know that A implies B and that A is true, since A implies B, then you also know that B is true. That's the law of detachment. The law of syllogism is pretty much the transitive property. The law of syllogism says if A implies B and B implies C, then A happening must imply that C is happening. That's the law of syllogism. Number 24, if it rains, then I'm bringing an umbrella to school. As I look outside, I see that it is raining. Thus, I carry an umbrella to school. This is an example of which one of those laws, Madeline? Is it the law of detachment or is that the law of syllogism? It says if it rains, then I am bringing an umbrella. Okay, what if I look outside? It is raining. So I'm bringing an umbrella, right? That's the law of... Okay, let me go over the two laws. Detachment. It is detachment. Let me go over them one more time. The law of detachment says this. If something happening implies something else happening, we know that if it rains, then I'm bringing an umbrella. If A implies B is true, and we know that A is true, which in this statement, A being true means it is raining. We know that if it is raining, then I'm bringing an umbrella. We look outside and we see that it is raining. Therefore, we know that what's true? Bring an umbrella. That's the law of detachment. A implies B is true. If we know A is true, then we also know that B will be true. This next problem. 25. If you give me $1, then I will buy a Coke. If I buy a Coke, then I'm sure to drink it. Thus, if you give me $1, then I'm sure to drink a Coke. This is an example of which law in? Is that detachment or syllogism? Syllogism. Don't put Newton's law. Okay, that's not this class. Next problem tests you on your different laws or properties of equalities. It says if x plus 3 equals 5, then x equals 2. We know this is true because of Trey. What do I do to get rid of that plus 3? What am I going to do to move that plus 3 over? Solve this equation for me. X plus 3 equals 5. To get rid of plus 3, I'm going to come over here and move it and do the opposite, which is the opposite plus, which is the minus. Okay. You're subtracting 3. That would be the subtraction property of equality. So by the subtraction C, the subtraction property of equality, we know that x must be 2. Number 27, line A is parallel to line B, and line C is perpendicular to line A. Let's draw it. Anytime you have a situation, I can't read that and make any sense of it. I have to draw it or I'm not going to get it. Line A is parallel to B. Let's draw line A and B. Here's line A, here's line B. They're parallel. Which, by the way, they're parallel because they have the same slope. I know those don't look parallel, but we're going to assume. Line A is parallel to line B. We're also given that line C is perpendicular to A. So let's draw that to be perpendicular. Line C is perpendicular to line A. What can we conclude? Cat, since this is a 90-degree angle, that's what perpendicular means. You got 4 90-degree angles. Corresponding angles, Cat. If this is 90 degrees, how big is this angle right here going to be? Because it's corresponding, correct? So does everybody understand if it's going to be perpendicular to A, it's going to be perpendicular to B as well? So that's what we can conclude. Line C is also perpendicular to line B, C. Next problem.